Welcome. Today we're talking about how to find the area of parallelograms. First, to review, we looked at the area of a rectangle in the last video. And to find area of a rectangle, you use length times width. Now, parallelograms are still two-dimensional shapes, so we're still going to have two dimensions. And rectangles are a special type of parallelogram, so we should expect there to be some similarities. But parallelograms have slanted sides instead of all vertical and horizontal sides. So if we try to grid this out, we end up with the grid lines going off of the shape. So let's look at this a little more closely. What do we remember about parallelograms? Well, I remember that opposite sides of a parallelogram are congruent. I remember that opposite angles of a parallelogram are also congruent. And I remember that opposite sides of a parallelogram are parallel, which means that the distance between those opposite sides has to be the same. So basically the height of the parallelogram is consistent all the way across. So that's those two taller white lines with the double congruency marks. Now what we've done here though, we've made right triangles because we had a height and a base, and we have a hypotenuse leg telling us that those triangles are congruent. So what happens though if we take the triangle off from the right side? We don't change it at all, we just slide it over to the left. We have a rectangle now that has the same height as the parallelogram did, and it has the same base as the original parallelogram did. So really, parallelograms have the same area as rectangles that have the same height and base. In rectangles we call them length and width, but you could call them height and base in a rectangle also. This does mean that the formulas are very, very similar for these two. So area of a rectangle, you remember, is area equals length times width, and we abbreviated that A equals L times W. Area of a parallelogram is just base times height, so we'll abbreviate it B times H. But that's the one that we're going to be using, the one that we're going to be referencing, the words that you should be looking for. So let's try it. Let's find the area of the parallelogram here that has a base of 7 units and a height of 2 units. Notice the height is always perpendicular to the base. It's not the slanted edge. Height and base are always perpendicular. So our area equals base times height. That's the formula that we just figured out. So since our base is 7 and our height is 2, our area will be 7 times 2. So our area is 14. Overall, we would officially say 14 square units for our answer because area is a squared measurement. But that would be it. You just multiply the height times the base and that's your answer. Now, just like we did rectangles backwards in the formula to find dimensions, we can do that with parallelograms also. So here's a parallelogram that has an area of 20 square units and a base of 5 units, but we don't know what the height is. Let's find it. Now we know area equals base times height. The base is 5, the area is 20. So we'll substitute those numbers in for their words, basically. So then we get 20 for the area equals 5 for the base times height. Divide both sides by 5. And then we get 4 equals h, which of course stood for height. And that's what we were looking for. 4 is our height. So now that we've practiced finding the area of parallelograms, we've practiced finding dimensions of parallelograms. That's all for today. Thank you for joining me, and I will see you next time.